Okay, Alg2T Trig, Chapter 1, Lesson 2, talking about domain and range from a graph. We've mentioned before how domain is really the set of all the inputs, which really means the x values that appear on the graph or the x values that work in a function. Sometimes you have functions where numbers can't work, like square roots can't have negative numbers into them, and those are things that wouldn't be part of the domain. Range is all the outputs or all the y values that appear on the graph. It's also kind of the idea of all the y values that the function can produce. You can put inputs in, and it spits out a function, spits out values y, and your domain is what goes in, the range is what comes out. So here is a graph with x values and y values. And you can think about which x values are appearing on the graph. A lot of people just want to jump to this x value here and this x value here because they're actually on the x-axis. But each of these points has some x value and some y value. Like this I could say is the point 2, 5. Well, it has an x value of 2, so 2 is in the domain of this function. -1 has an x value somewhere, -3 has an x value somewhere, even -5 has an x value somewhere. In fact, every x value appears somewhere on this graph, because even though 3 looks like there's nothing on it, this graph is going to shoot up and over forever and ever and ever. So every single point on the x-axis, every input, will correspond to some output up here somewhere. That means the domain of this graph is all real numbers. I can plug anything in for x and it'll spit out a y. Range is all the y values. You kind of play the same game, but before, with domain, we were comparing to the x-axis. With range, you compare to the y-axis. So there is a point that has a y value of 5. I mean, that was an x value of 2. I don't really care. There's a y value somewhere. So 5 is in the range. 3 is in range. 0 is in range. -3 and -4 and 18. Everything is in range except for stuff below -6. Because this graph doesn't go below -6. So the range of this graph is that y is greater than or equal to -6. It's everything from -6 up. And we said the domain was all real numbers. Now, when I think about graphing and with domains and range on graphs, I actually think about scanners or copiers. Here's a creepy picture of SpongeBob, and I say it's creepy because his eyes are always so big and so open. But if you think about a scanner or a copier, the way that it works is you take your picture of SpongeBob and you slap it down on your scanner and you shut that big heavy lid and press the button and this green light goes and kind of runs along here. And what that green light is doing as it runs along is shooting light up through the paper. And if the light doesn't hit any ink, it doesn't make any record of it. But once it starts hitting ink, it tells the computer to remember, oh, at this point and this point and all these points and this point and most of these points here, there was some ink. And on the grid, make a note of the point of the coordinate at which there was ink. So when we make copies, we'll make sure to put ink at that point also. And that's essentially what domain and range do. You run along. I literally think about having a scanner almost every time. And to find the domain, I run along the x-axis. I think about this x-axis right here like it's a track. Like this is the track that my big domain line is going to run along. And as it runs along, is it hitting the graph here? And it actually is, because like we said, this graph is pointing up forever and going over forever. So it does hit the graph there and hits the graph there and hits the graph here. And it's going to hit the graph everywhere. There's no point where this scanner wouldn't tell the machine to make some ink. So the domain is all real numbers. For the range, we just take it and we run along the y-axis instead of the x-axis. I like to start down below. I'm not hitting the graph, excuse me. Not hitting the graph, not hitting the graph, not hitting it -6. And from there, every point up, we're hitting the graph somewhere. Hitting it here and hitting it here in this case. So the range starts at -6 and goes up. And we can include the -6, so we say it's greater than or equal to. Okay, there's two ways to write domain and range. There's set notation and there's interval notation. Set notation is probably what you're more familiar with, where you say, like, I just made up these domains and ranges. They don't relate to anything. But x could be less than -3 and x can be greater than 8. Less than or equal to includes the value. The equals to includes the value. And so here the range, y is less than 4, or this means that -3 is less than y, which is less than 7. sorry, negative 3 is less than y, which is less than or equal to 7. But what this really means is between. When you see that, just think y is between negative 3 and 7. Interval notation does the same thing, but it uses parentheses and brackets to accomplish what less thans and greater thans accomplish. So this domain here matches up with this domain here. This is saying x is less than or equal to negative 3. This is saying x can go from negative infinity, from negative infinity to negative 3. Here, x is greater than 8. Well, here, x can go from 8 to infinity. We always use brackets if we are including the point, and use parentheses if we're not. You'll never use parentheses on an infinity symbol, because you can't actually include infinity. You can't actually grab it and hold it. In the same way, this was range is between negative 3 and 7. Here's between negative 3 and 7. I guess I also forgot to say that y could be less than 4, so that would also be negative infinity to 4. That's the other part of that I forgot. So let me do a simple example. This hopefully can kind of clear any confusion up you might have. I have a simple segment that doesn't even go in both directions forever, a closed circle to represent included, an open circle to represent not included, and we'll start with domain. With domain, I'm checking to see which x values occur. I'm kind of trying to see here what's going on. The domain is really going from negative 3 to 3, but you're not including the 3 itself. So if I wanted to write this in set notation, the domain would be x is between negative 3 and 3. And actually when you write this, I'm going to get a little bit more fancy here. You're supposed to use what I call these wing brackets. This is saying the set of all numbers x such that negative 3 is less than or equal to x, which is less than 3. So I'll read it out as I say it. The set of all numbers x, this vertical line means such that negative 3 is less than or equal to x, which was less than 3. And there's your set notation. Then for the range, I'm not checking the x values, I'm checking the y values. So whoa, I don't even know what just happened. Did I just delete it? Or did I just go down? Huh. Come back. Come back. Thank you. I'm not checking the x values, I'm checking the y values. So that's really thinking from here to here, this stretch of y values included the graph. So the range is going to go from, it's the set of all numbers y such that y is between 1 and 4. Y is between 1 and 4. If you want to think about a scanner, domain, not hitting the graph, start hitting it here at negative 3. Keep hitting it until 3 where you don't hit it. And then the open circle means just at that point 3 I don't hit it. So I can include 2.995 and everything right under 3, but not the 3 itself. And then for range, I don't hit the graph, but I start hitting it at 1, and I keep hitting it up until I'm almost at 4, till the y value is almost 4. So here's 4 that you can try. Pause the video, give it a shot, do it in set or interval notation, I don't care, I'll do both. It's going to take me a while to go through all 4 of them well, but I'll try and do it quickly. But at this point we're just doing examples to check. I'll start with the domain of the first one. I start hitting this sideways parabola at negative 3, and I keep hitting it forever. So the domain of this, in set notation, would be the set of all numbers x such that x is greater than or equal to negative 3. And the 3's keep looking like wing brackets, so I should hope these get different numbers. The range of this, well, even though you don't really see it, this graph is actually pointing up and down forever. I mean, right now it looks like I'm not hitting the graph anywhere, but this is actually going like this, on forever and ever and ever and ever. It's always pointing down somewhere. So the range is all real numbers. And the way that you would write that is you can say 2 ways really. Y such that y is in all real numbers, And this little backwards 3 thing means in the set of, or you could say that the range is the set of all numbers y such that negative infinity is less than y, which is less than infinity. Y is between negative infinity and infinity. For interval notation, I'm going to do basically the same thing. The x values, we're going from negative 3 on. So my interval is going to be from negative 3 to infinity for my domain. And for my domain, and for my range, the interval is negative infinity to infinity. This red one is not a function. That's okay. Things that aren't functions can still have domains and ranges. The blue one is a function. It's not a one-to-one function, for what it's worth. But domain, if I scale left to right, is all real numbers. There's no point at which I'm not hitting the graph. I'm really hitting it here, and hitting it here, and I'm hitting it everywhere here in between, and everything after. So the domain is all real numbers. If you wrote that, I'd be okay. But the actual way you should write the set notation is saying the set of all numbers x such that negative infinity is less than x, which is less than infinity, or the set of all numbers x such that x is in the real numbers. Those would both be the domains. The range is also all real numbers. If I was going to do that by interval notation, it'd be negative infinity to infinity for my domain, and negative infinity to infinity for the range. Next, this one is really helpful and useful. It's got 3 different sections. Domain, I'm not hitting the graph here at all. I start hitting it at negative 6. And I keep hitting it all the way up till I'm almost at negative 4, but I can't actually include negative 4. So the domain here is the set of all numbers x, my wing bracket was really poor there, such that x is between negative 6 and negative 4, including the negative 6, but not including the negative 4. Then it keeps going. It's also from negative 3 to 1. And then it's from 4 on. It continues, not including 4, but everything after 4, from 4 on. So it's also x is greater than 4. That would be how I would write this domain. In interval notation, I think this is where interval notation is better. It's going from negative 6 to negative 4, including the negative 6, but not including the 4. Then it's going from negative 3 to 2, including both. And then it's going from 4 on, not including those. And technically now, I should be putting little u's between these, which means it's the union of those sets. If you don't do that, I won't mind. But if you want to learn how to do this, you want to have the unions in there. I'll do range now. Range is the y values. I am actually hitting a y value here, because this line is pointing down forever. So I actually hit the y values, I'm hitting it twice now, doesn't matter. Here I'm almost hitting it 3 times except for that little hole, so I'm only hitting it twice and hitting it twice. And then I keep hitting, I stop hitting at 5. So the range of this graph is y such that y is less than 5, and I do include that 5. And the range of this thing in interval notation would be from negative infinity to 5, including the negative 5, but not including the negative infinity. Ranges and domains should always go from least to greatest as you list them. In either form, set or interval should always go from least to greatest. Okay, last one. This is going from negative 6 to 1. It's going from 0 to 3. And it also just includes 5. It's x such that x is all these numbers. That's my domain. I could also list it as from negative 6 to 1, inclusive, with the union, a u for union, meaning including both of these, 0 to 3. And also just including a plain old 5. range is actually much simpler. It's just the numbers 4, 2, and 1. And I'll list it from least to greatest, so 1, 2, 4. The range is a set of all numbers y such that y equals 1, 2, 4. And it's going to be the interval of 1, 2, and 4 in brackets with unions between them. Hope you find that helpful. Hope you can come back to this and watch it over and over. I think it's something we're going to come back to a lot, but there you go.